Howdy folks, Jeremy KF79JZ from the HamRadio360 podcast, making a very quick and dirty video before we record tonight's episode. On the bench, I have 4 multimeters and my electronic load. Currently hooked up to a 9 amp hour AGM battery. The load is currently turned off, but I wanted to take a moment to compare the quality of the meters. On the bench, we have a Tenma 721020 benchtop meter. I have a Fluke 287. We have a Tenma 727780. And I have a 7210 415. Now, ignoring the DC load, the bench unit sells for about $230. The Fluke is about a $430 meter. The 7780 here in the middle is about a $60 meter, and the 10415 here on the far right is a $100 meter. Unfortunately, I just have a mess of wires, and they are connected to the battery itself. So I'm going to pull back and get the discharge test started, and we will measure the voltage at the battery as it drops. Alright, so I have this in battery test mode, and I've set it to discharge at 0.5 amp. So we'll go ahead and get that started by pressing the on-off button. We're now at a constant current discharge, and you will see the value of the battery start dropping. All of these meters are reading at the battery, and one of the first things I wanted to kind of compare was how quickly they update. Looking at our 2 most expensive meters, you'll see that they're about in the same range, but it looks like the Fluke updates at about twice the rate that the benchtop meter is updating at. If I look at our most expensive, our least expensive, in the middle of the road, you'll see that the Fluke is still updating about twice as quickly as the 2 other meters, but you'll notice that they're tracking in value pretty well. If I come over here, there is still a little bit of a difference between those two, but the meter in the middle is not incorrect, and unfortunately this isn't necessarily a good test to get an idea of how quickly its display updates, because the rate at which we're discharging the battery just isn't making a voltage change big enough. I'm really impressed at the nice Tenma there on the right, the 10415, and how close it is to my Fluke. Alright, we've now got the discharge rate set to 10 amps, which is a lot. Now we're going to see these voltages drop real fast. And we didn't quite get a lot of sample, but the 2 Tenma meters certainly seem to update at approximately the same rate. If I turn it off, test is off. You see the voltage jump back up. Now if I turn the load back on, so you saw how quickly the 7780 updated. That was actually quite impressive, because that seemed like it was going more than 1 update per second, so that's pretty impressive. Again, having the extra digit of precision is nice, but for most things that we're doing, not necessarily critical. And one of the things, as far as testing this, there are ultra-precise voltage references that are available, but I will also point out that I'm using some incredibly cheap leads here, and that may be contributing to this. Whereas the Fluke has Fluke leads, and both of these 2 meters have Tenma leads. So for the next test I want to do here is we're going to look at continuity. And I have all of these meters in the ohm meter position, and all of them have continuity test, which is indicated by the little symbol for the radiating sound to demonstrate that they're in continuity test. One of the things that's really important for meter is having a continuity test that sounds quickly. So we'll start here with the Fluke, and all I'm literally going to do is touch these together. And this is the Fluke. You really are just trying to see how quickly it sounds. So that's the $400+ Fluke. Here's what it looks like when continuity happens. Next, we will try the $60 727780. That responds instantaneously, just like the Fluke. Nothing really special on the display, but also very good. And then finally, the $100 7210 Here are the leads for that. I'll point out, these are not the leads that came with it. These are another set of leads I had that I thought were higher quality. But still, that's pretty much instantaneous if you have good leads. Alright, so I have my Fluke leads plugged in. See if you can see Fluke. Let's see how this guy does. There is, surprisingly, for what is the most expensive Tenma on the bench, there is just a tiny bit of delay, which is kind of annoying. One feature that I didn't even know about on my Fluke here is I'm getting ready to get set up for a current test. So I still have it on the ohms, and down here I plug the lead into that, and it warns me that the leads aren't connected correctly. So we'll throw this over here into the current mode. No, it's not complaining. Alright, for these current tests, I'm going to set the load up at 0.5 amp, and what's cool, as it's running, I should be able to manipulate this to show the changes on the meter. Now, to measure current with a meter, you basically put the meter in series with your circuit, and in this case I've broken the circuit to the load, and I'm using alligator clamps and very small wire, which is why I'm keeping the current small, to attach that. In fact, 0.5 amp is too much. I'm going to turn it down to 2/10, because that's probably only like 20 gauge wire, and that will significantly reduce the voltage. So we'll start with the Fluke, which is on amps DC. Everything is hooked up properly, so effectively, again, the meter is in series with the circuit. So if I start the load, here I'm seeing I'm drawing 0.2003 amps. If I come over here, I see 0.2015. Now, if I adjust it up, and I'm only adjusting the 10ths position, what's interesting is it's pretty consistently moving just the 10ths position, and those last two digits are kind of staying in that 14 to 17 range. So I've now got it down to a 10th. So as I spin it, it surprisingly responds very quickly. Alright, I've got my middle meter hooked up, and of course you always want to double check that your probes are in the correct position. In this case, common current. I now want to make sure the meter is on the correct position, which in this case we're now in amps, DC, auto ranging. And if I come back over here, and I'm going to set this at 1/100th of an amp, and I turn it on. Over here, I'm seeing I am accurately reading 0.01. Now if we turn it up, it's on it is on 0.3, just to show it did actually, that was my fault for it jumping. That's on 0.2, 0.4, 5. What's interesting is it's changing instantly on the meter. This is kind of walking up to get to that current. So what that tells me is if you're measuring current, you might have to wait a second for the number to settle. But again, it's a $60 meter. As long as you're not trying to chase down something that's happening in real time, you should be fine. If I crank this bad boy up, so this says I'm on 0.29, 0.29. That's very, very impressive. So that was the 727780, or the $60 meter on the current test. Okay, I now have the $100 7210 415 hooked up. Got them in the correct positions and turned on the current setting. Set up for DC current. The load is presently off, so I'll turn that on and do 1/100th of an amp. If I come over here, getting the same reading, 0.011. 2, 3. Nope, in fact I did jump to 4 again. The dial's not very precise. 1 click. 5, 6. Just randomly spin it. 0.23. 0.23. Now notice about this meter, it's not really having to count up. So I just spin the dial, 0.35, pretty instantaneously, 0.35. Also very impressed with the accuracy of this. If I just spin it a whole bunch down so I don't get the current too high, 0.23, 0.23. Very impressive. Alright, finally we'll do the $230 721020. Got things plugged into the correct ports, on the correct mode. I'll go ahead and start this. We're at 0, turn it to 0.01. Well, that's interesting. Just to show, same setup. In fact, these are the same test leads I just used on the last meter test. 0.01 amps. And I'm only getting 0.006. Let's try it to 2. 0.016. 0.02. Now we're on 0.03 and we're 0.025. We're on 4, 5, getting closer, 6. So I currently have it on 0.07, it's reading 0.067. I'm curious if we adjust the number we're on, now changing the milliamps, 0.068. So it is reacting to some small extent to those. If I come back over here, crank this back up, and then we'll move that back into that position. So I'm just going to crank it up randomly. I've got it on 0.17. We're reading 0.166. Now, this is close enough, and this meter should be fairly accurate and very precise. Again, good enough and way more precision than we need for amateur ham stuff. I will claim some ignorance because this meter actually has some setup options, and maybe I don't have something set right. So I don't really want to comment too much on that. But if I turn the current way up again, or that's down 0.21, 0.208. I believe it. So it's entirely possible that on the lower end of the current range, this thing isn't quite as accurate. So if I turn it back down to say 0.05 amps or 50 milliamps, getting 0.046. So again, that may be actually the truly accurate and precise measurement. So it occurred to me there's one other test that I should conduct, and that test is sensitivity to managing milliamp current. So each one of these meters has a port dedicated to million microamp readings, and this is something that is often a challenge for multimeters. Here on the Fluke, there's a maximum current reading of 400 milliamps. On the Tenma 7780, we've got a maximum current of 600 milliamps. On the Tenma 10415, you have a maximum current of 1 amp. And on the 1020, we have a maximum current of 400 milliamps. So I've got the Menuo load at that position of milliamp position, and I've got the meter wired in series. I'm just going to move the probes between meters for this test. So we're going to turn it on 1 milliamp, and we'll start the test. So I've got it set on 1 milliamp, and the meter is actually reading 2. I've got it on 2. Nope, actually I have it on 3. It's reading almost 4. 4, it's reading 5. Got it on 5, it's reading almost 6. And just to show, 5 milliamps, we're getting, 5 milliamps, we're getting 4.8 milliamps actual. But here we're reading high. Now I've got it on 100 milliamps, still reading on 1 high. Let's crank this up faster. Now on, still reading 1 milliamp high when I've got it on 200 milliamps. Crank it up to 300. Still reading 1 milliamp high. So consistently, this is off by 1 milliamp. Now let's test the 7780. So the load is turned off on the 7780. I have it in the milliamp position. And we'll start again with our 1 milliamp test. Interesting. It's also reading 2 milliamps. Crank it up to 10 milliamps. It's reading 1 high. So I'm going to crank the load up to 500 milliamps. Still reading 1 high. So this meter is also consistently reading 1 milliamp above the actual, well, I should say the reported. Alright, I've got the 10415 on milliamp mode. And we're going to start the test again with 1. We'll turn it on. Reading 2. We'll crank that up to 10 milliamps. Reading 1 high. Take it up to 2. Still reading about 1 high. So these 3 meters consistently are all reading approximately 1 milliamp higher than the actual reading. But I'd say that's probably still pretty good precision and or accuracy for the types of things that we're going to be working with. Alright, I've got the 1020 hooked up. Unit is off. Put 1 milliamp on. Start the unit. Well, that's interesting. It's kind of bouncing around, but still reading about a milliamp high. If I crank it to 10, still reading about a milliamp high. Now let's crank it to 100 milliamps. Still reading about 1 milliamp high. And now I can crank it to, we'll do 2. Still reading about 1 high. 3. Still reading about 1 high. So all of these meters are consistently reading the current 1 milliamp too high. Again, still a really good result for these meters. So I think our takeaway is that all of these meters are going to be really good for doing the type of work on the workbench that we're going to be doing projects, working with small digital ICs or microcontrollers, single board computers, building small low power circuits. All of them are going to give you the features and the precision and probably the accuracy. Again, unfortunately, I don't have a way to actually test accuracy for resistance measurements or anything like that. I don't have any standards to reference. But I think you would be quite happy with any of these meters. So I got the Turnigy hooked up, and one of the things that's cool, see the voltage readings are the same. But in the grand scheme of things, there's 200 feet, sorry, it's not 200, 2.5 feet of like 12 or 14 gauge cable between the battery and this now, so the voltages won't match under load. But I've got it set on 0.05 amps. If I turn it on, you'll see that it's not even registering 0.05 amps. And MJ Lorton actually did a video on these, and this was the reason why the What's Up was better. This isn't really going to start reading current is at about a tenth of an amp. So, see if I can get them both in screen. You'll just notice nothing. Doesn't see the wattage, nothing. So this is truly a high power meter. It starts to register at 1/10 of an amp. And actually it gets the voltage, well, it's such a low current the voltages would be close, but I can crank this guy up. So 0.2, that's accurate. Let's put it in a bigger digit number. So now we're 0.92. Okay, that's accurate. 1.02, still good. Now there's no, here we are, 7 amps. It's reading 7.02, spot on. And now I've got it 11, which I'm now doing something that none of these multimeters can do. And that's 11 amps of current. I better turn that down so the voltage doesn't get too low. But useless below 0.1. And you'll notice the refresh rate's a little slow, but as a power meter, these things are pretty good. But a different tool for a different purpose than all of our multimeters. Special thank you to MCM Electronics for providing the Tenma units for evaluation and this demo. Thank you very much for listening. Don't forget to like and subscribe. 73.